Welcome back to the laboratory, dear friends. Tonight, the Society examines a machine that did precisely what it was told and tore itself to pieces for the trouble. It is the morning of the 4th of June, 1996, on the northern coast of South America. At the European spaceport at Kourou, a brand new rocket stands steaming in the tropical heat. Ariane 5, 10 years of work and the pride of a continent. In its nose ride four identical silver satellites, built to fly in formation and study the wind that blows from the sun. The count holds a few minutes for cloud, resumes, and the engines light. The rocket rises, straight and clean and beautiful. 30 seconds later, it is confetti over a mangrove swamp. I am the Magnanimous Doctor Warthan, and this is the Broken Machine Society. Case file number 7, the number that would not fit. If you enjoy watching very expensive things become very small pieces, do tap that like button. The society is not proud. Now, let us admire the patient, for she was magnificent. Ariane 5 was Europe's answer to a simple question: who shall carry the heaviest things to orbit? She was not a modest revision of what came before. She was new. New engines, new boosters, a new shape, and a first flight that would carry, as a courtesy, a scientific mission called Cluster. 4 spacecraft, identical as quadruplets, meant to fly in a great tetrahedron above the Earth and measure the invisible weather of space. Their scientists had waited more than a decade. They flew on the maiden voyage because a ride on a test flight was cheap and the risk was known, and space science has never been a wealthy business. And in the rocket's belly sat a device called the Inertial Reference System. Its job is the oldest job in navigation: to know which way is up. It feels every push and every turn and keeps a running answer to the only question that matters to a rocket: where am I pointed and where am I going? There were 2 of them aboard, side by side, identical twins. One flying, one watching, so that if the first should fail, the second would carry on. Remember that, dear friends. Remember the twins. Now here is where the Society must introduce a small, harmless, well-intentioned piece of housekeeping. Before a rocket flies, its navigator must be aligned, taught precisely where it is standing and which way is north. This takes the better part of an hour. And on the older rocket, Ariane 4, some clever engineer had noticed a nuisance. If the countdown stopped in the final seconds, you had to do the whole alignment again, and the launch window would close, and everyone would go home. So he arranged for the alignment routine to keep running a little while into the flight, just in case the count resumed, so the rocket would not have to be taught its own address twice in one morning. A thoughtful solution. It was used in the entire history of the program exactly once, in 1989. And when the engineers built the new rocket, they carried that same trusted, decade-proven navigation software across, unchanged, because it had never given anyone a moment's trouble. Including this one small routine, still faithfully computing the alignment of a launch pad the rocket had already left. Speaking of things that no longer serve any purpose, I am told it is time for a brief word from tonight's sponsor.
I have no sponsor. Even light does not return my calls. Now, where were we? Yes. Inside that pointless little routine, a number was quietly growing. The engineers called it the horizontal bias. Think of it as a measure of how much sideways motion the navigator is sensing. A number that, sitting still on a launch pad, stays politely near 0. But the rocket was not sitting still. It was climbing. And so the number began to swell, and the routine, believing itself still bolted to the ground, dutifully wrote it down. And here, dear friends, is the whole tragedy in one small act of clerical work. That number lived in a large and generous box, and it had to be copied into a smaller one, a box that could hold any whole number from about minus 32,000 to plus 32,000. On Ariane 4, that had always been enough,
because Ariane 4 gathered sideways speed gently. But this new rocket was a different animal and built up horizontal speed 5 times faster. And so, 37 seconds after the ignition command, 30 seconds after she left the ground, the number arrived at the little box, and it would not fit. Now, the navigator was not built to shrug. Its instructions were explicit. If you encounter an error you do not understand, assume your own hardware has broken, announce the failure, and shut yourself down. Which it did, instantly. And the twin? The backup, the survivor, the whole reason there were two? The backup had already died, 1 heartbeat earlier, about 5/100ths of a second, because it was running the same software, doing the same arithmetic, on the same rocket, and it had met the same number. Two healthy machines, in perfect working order, switched themselves off within a breath of each other. That is the trouble with a spare, dear friends. A spare protects you from bad luck. It cannot protect you from being wrong. What happened next was almost polite. The dead navigator, shutting down, put a little diagnostic message onto the wire, a note explaining what had gone wrong. And the flight computer, which was working perfectly and had no way to know its navigator was gone, read that note as fresh navigation data. It concluded that the rocket had lurched violently off course. It had not. And so, faithfully, correctly, and with admirable speed, the computer commanded a correction for a disaster that had not happened, and swung the engine nozzles as far as they would go. The rocket obeyed. She turned, hard, into a wall of air at twice the speed of sound, and the sky took her apart. The boosters ripped from her flanks, and the self-destruct fired automatically, exactly as designed, 4 kilometers up and a single kilometer from the pad. Burning debris rained across 12 square kilometers of swamp and savanna. Nobody was hurt. There was no one to hurt. An uncrewed test flight over empty mangrove. The inquiry was led by a mathematician, and it was quick and unsparing. 6 weeks. And its findings were not, as legend would have it, that a programmer was careless. 7 values in that navigator could have overflowed. 4 had been given protection. 3 had not. And that decision had been made deliberately, on paper, reviewed and approved, because the little computer had a strict budget for how hard it was allowed to work, and someone had calculated that those 3 numbers could never grow large enough to matter. On Ariane 4, they never could. The calculation was correct. The rocket it described had simply ceased to exist. And the final indignity. The navigator had never been tested on the flight it would actually fly. Nobody had ever fed it the real trajectory of the real Ariane 5 and watched what happened. Had anyone done so, on any afternoon in those 10 years, the failure would have introduced itself immediately. The board wrote 14 recommendations. The first one is the one worth carving above a door. No software should run during flight unless it is needed. And the ending, dear friends, is better than the beginning deserved. Europe rebuilt the 4 satellites and got them to orbit in the year 2000 aboard Russian rockets because that was what the budget would bear. A European mission rescued by an old rival. They were meant to work for 5 years. They worked for 24. The last 2 are scheduled to come home and burn up in the atmosphere within weeks of this recording, having spent a quarter of a century mapping the invisible weather of the sun. And the rocket? Ariane 5 flew for 27 years and 117 missions and became one of the most reliable machines ever built. On Christmas morning, 2021, she carried the James Webb Space Telescope so precisely that she added years to its life. The machine that failed in 30 seconds delivered humanity's finest eye. And here is tonight's lesson, so listen closely. Every machine you rely upon is standing on a pile of assumptions, and most of them are true. The danger is not the assumption that is wrong. The danger is the assumption that was right, that was carefully checked, honestly documented, and correct for years, and then quietly stopped being true while nobody was looking, because the world around it changed. Software does not rot, dear friends. It stays exactly the same. That is precisely the problem. And so the society closes the folder on the number that would not fit. Case closed. Next time, before the society, a mathematics professor in Virginia, a brand new computer chip that could not quite divide, and a corporation that decided for 6 extraordinary months that this was not worth mentioning to anybody. Stay curious, check your assumptions, and do not trust a twin.
The society is adjourned.